look at the, I'm just gonna go through, we did we did the procedural review yesterday, so we'll look at the non-graphing calculator review, and then hopefully we get through the whole graphing calculator review also. Whatever time we have left over tomorrow, so hopefully it's whole period, I'll give you the lab and then we'll start testing Friday. So let's take a look at these. There's some problems on here that have to do with properties of exponents. Okay, so let's quickly review the properties of exponents here. Now, when we get something like this and we're supposed to simplify, what are we going to do first? We can distribute, good. So when we have a product of two things to a power, remember that then we distribute the exponent to the factors. But here's the mistake people make with that. If I have something like x plus y to the fifth, can I distribute the power? No, can't do it. You can only distribute when things are being multiplied, not when they're being added or subtracted. Remember, this is ugly. Remember what that means. That means x plus 5 times x plus 5 times x plus 5, etc. So that's going to be a huge mess, right? This is much easier when you have a product to a power. Okay, so if we distribute the negative 4, we're going to get x squared to the negative 4 times y to the fifth to the negative 4. And what's our rule? If we take a power to a power, what do we do to the exponents? Multiply, right? When we multiply like bases, that's when we add exponents. But here we're taking a power to a power, so we multiply. And that's just going to become x to the negative 8. And this becomes y to the negative 20. And now what's our rule? We have negative exponents, right? We want to write the answer in terms of positive exponents. So what do I do? Good. And our rule that we said was a negative exponent on the top is positive on the bottom, and vice versa. A negative exponent on the bottom becomes positive on the top of the fraction, right? So then we would just write this as 1 over x to the positive 8th, y to the positive 20. Those both have to go to the bottom of the fraction. So now, in Moodle, how would I input that?
1 over
1 divided by parentheses, good. X to the 8th, y to the 20th, right? Okay? Good. All right, next one. Okay, this one, this is similar. Okay, if people miss this one, what do you suppose the most common mistake is here? Good. They only distribute the power to the x, but there's two things there. There's a 2 and an x to the 4th. And so that power of 4 has to get distributed to both parts, right? So I'm going to get 2 to the 4th times x to the what? 16. And what is 2 to the 4th? No. 16. Yeah. So that's just going to become 16 x to the 16. Okay? Okay?
Got it.
All right. Push on. Oops. Okay, these guys. Okay, now remember with these, how we organize these. These look hard, but they're not. They're easy. We break this up into 3 parts. We're going to break it in this case. We're going to break it up into the numbers we got to simplify, and that's the hard part. And then we just have the bases. We have 2 different kinds of bases, x's and y's, right? And so if we look at just the number part, let's the number part we're going to put in red. What is the number part going to simplify to?
5.
20 over 4 simplifies to a 5 on the top, right?
Yep.
Everybody agree? Okay, so taking care of the numbers in my big fraction I'm going to get, I get a 5 on the top. And if I never get anything in the bottom, I don't even have to make a fraction, right? I don't have a fraction. I just have an expression. Now, what about the x's? We'll make those blue. Okay, good. So if I have x to the 10th divided by x cubed, what's our rule for dividing like bases?
Subtract.
Subtract, or you can think of it as canceling if you want to. How many are left over on the top? 7. Good. Okay, and then the y's. Good. Okay, I'm going to cancel a bunch out and be left with how many on the bottom? 8. Good. So there's my answer. Now when I enter that, I'm going to want to go ahead and put everything in the top in parentheses, right? On the bottom I don't need to though, because there's only one thing there. Okay, I don't need to in this case. Right? But if I had multiple things in the bottom, I'd have to put them in parentheses. Questions? Okay? All right. Okay, these kind are really pretty easy. All we're doing with these, let me make this bigger so everybody can see. Okay, all you're doing with these, and we won't even go through the whole thing, but if I'm adding or subtracting polynomials, that is very simple stuff. All I'm doing is just combining like terms. Let's get all the phones and stuff away. I'm concerned that we're getting down to crunch time here, and I want to make sure everybody's getting through this stuff okay. But it's, right, thank you. Okay, so what about this then? We got to look at, I've got some x to the 4th terms I got to attend to. So I've got x to the 4th plus 6x to the 4th would be how many x to the 4th? 7. And this is kind of weird. This thing is, it's all out of order. I'm not sure why, but you just got to hunt through there and find the right one. So it'd be 7, right? And then I'm going to do the same thing for the x cubes. How many x cubes? Just one of them right there, right? How many x squareds? Just one of them. How many x's? I would get 2 of them, right? And then the integer, just 2 at the end, okay? So that's easy enough. Now when I'm multiplying, this is a little bit tougher, and what you got to do with these is just you got to be very organized. You really want to be using lots of paper on the test. You do. You want to be writing this out, so you write it big, you write it out, so you have a chance to not make little errors from just being messy. So with something like this, let's go through one of these just to review how we do this stuff. Okay, so now just a couple things, and not that this is a huge deal, but it helps you organize things. Do I want to distribute from the second polynomial to the first one, or vice versa? Second to the first one, because it's only got 3 terms, so that's less distribution to do, right? So let's distribute from this guy to this guy. So the first term now you can do this however you want to, whatever works for you, but I really believe that stacking them vertically helps. If you're not doing that, try that. I really think that helps. So if I distribute the 2x squared all the way through, what's my biggest term going to be? My biggest target? Yeah, so I'm going to get a 2x to the, if I multiply like bases, do I add the bases? So it's 5th. Right, when I'm multiplying like bases, I just add the exponents. It's when I take a power to a power that I multiply exponents. Okay? So now what about this? 2x squared times x squared? 2x to the 4th, but I want to make sure I have columns for each power of x, so I don't have to skip anywhere. That's going to be the next column, isn't it? But I want to make sure I've got those columns set up for each power of x. 2x squared times negative 3x.
Negative 6x cubed.
Okay, 2x squared times 2.
4x squared.
Okay, good. Now let's distribute the x. So if I do that, x times x cubed, so that's going to line up in this column. So that's a positive x squared, right? X times x squared.
X cubed.
Plus x cubed. X times negative 3x. And then finally x times 2.
2x.
Okay, and then last one, if I take that negative 3 and distribute that all the way through negative 3 times x cubed,
Negative 3x cubed.
negative 3x squared, positive 9x. Get those, and see that's an easy mistake to make. Put a negative instead of a positive there.
Six.
And then negative 6. Okay, all I gotta do is just add those up. And if you line them up vertically like that, to me it just seems like it's an easier way to organize it. When you have a whole string of that's a big string of numbers. When you're trying to cross those off horizontally, it's so easy to just forget one or something, right?
Yeah.
So then we would just get 2x to the 5th plus 3x to the 4th minus 8x cubed, negative minus 2x squared plus 11x
Minus 6.
minus 6.
You got that one.
Right? Okay, questions?
That was big.
It is. Those are time consuming.
I get.
Okay, so these. Now these should be gimmies. This should be an absolute freebie for you. What does this mean here? So they're wanting us to decide, let me make this a little smaller so we can see. Oops, wrong way. So we're going to take this polynomial, f of x equals 10x to the 9th plus blah, blah, blah. And we want to know, what does f of x, that's just y, what does f of x approach as x approaches negative infinity? Okay? So that's the key part of this thing right here. As x approaches negative infinity, we're just trying to answer the question, f of x approaches what? My answer is always going to be negative infinity or positive infinity, right? You know that the polynomial is always going to get really big, either up or down, when I go far out to the left or the right. Now, if I'm going, x is approaching negative infinity, I'm going clear out to the left, right? All I care about, though, this is so easy to do, all I have to do is look at the biggest power of x. The leading term is the dominant term. That's the only one that's going to make any difference. So all I do is I just analyze that first term, right? So I'm going to look at that, 10x to the 9th. I know the answer is going to be infinite. The question is just, what's the sign going to be of the number? I'm going to get a really huge number, but is it positive or negative? So all I have to do is just figure out what's the sign of that first term going to be if I'm plugging in a negative number. That's it, right? If I were approaching positive infinity, I would just want to know what's the sign of the first term when I plug in a positive number for x. So what's that going to be? If I'm taking that first term, 10 times x to the 9th, and I'm plugging in a negative number for x, well, a negative number to the 9th is what? Negative, right? A negative number to an odd power is negative, right? Negative number to an even power would be positive. So then if I put in 10 times a negative to the 9th, that's going to give me a positive times a negative equals negative infinity, right? So what's it tell me to do then? If it's negative infinity, I enter negative 999, okay? Make sense?
That's easy.
Okay, very simple.
You go to the
Yeah,
light.
go ahead. No, there's no chance. Don't even ask. We're not going to go today. Okay, yeah.
You go next week.
Oops. Okay, so we're going to go next page. Okay, so what about this one? Same kind of question. As x approaches positive infinity, what's that sign of that first term going to be? That's all I'm looking at is the first term,
Easy too.
the biggest one. So negative 14 times a positive number to the 10th is going to be
Positive.
what?
Negative.
What? Why would it's going to be negative, right? Because I have negative 14. What's a positive number to the 10th?
Positive.
Positive times negative 14 is
Negative.
negative, right? Make sense?
Yes.
Okay. All right.
Ooh, that bomb was scary.
Okay, factor the expression. And our answer just needs to be the factored form of this. So 8x cubed minus 1,000. Now let's go do this on the other page.
That one's so big.
Okay, so now if I'm gonna factor this, how many terms? Two, right? Two terms. I've got something minus something, so two terms. That means I'm gonna use what strategy? Yeah, pattern, difference of cubes in this case. So I just need to know what is my difference of cubes pattern. So difference of cubes, a cubed minus b cubed equals, I need more space, that's not gonna work. A cubed minus b cubed equals, and you gotta know those patterns. So what's this one?
A plus.
Minus, it's minus, because whatever that is, goes there.
A squared.
Plus.
Plus
B
B.
AB.
Minus.
And then the last one's always plus. Plus B squared. Okay? So that's the one I'm gonna use. Okay, but before we even do that, we always, before we even start factoring, we wanna ask ourselves, can I factor anything out? Is there a number that goes into both of those?
2.
2 does. Anything else? 4 does. 8. 8 divides into 1,000.
12.
Yeah.
Just kidding.
So I could take this thing and right away, I could factor out an 8, leaving me with what? Well, x cubed minus 8 goes into 10 once, with 2 left over. 8 goes into 20 twice, with, that's 2 times 8 is 16 with 4 left over. 8 goes into 40
About that.
5 times.
Oh yeah.
Why do you leave the 8 there?
Because that's a common factor. If we're trying to factor this thing, I'm gonna undistribute the 8, but I have to leave it there. Now, if I were just solving for x, it wouldn't matter, but it actually wants me to write this in its factored form, and so I need to have that 8 there. Okay. When I'm all done, the answer that I have, if I were to multiply it all out and undo all my work, should give me that, right?
Wait, so why do you have the whole left cube staying up there and blue?
Well, that's the pattern I'm going to use, because now look, I've got x cubed minus 125. This is the pattern that's going to be a difference of cubes, okay? So I've got to take this stuff right here, and I've got to match it to that pattern, right? So what's my a this time, and what's my b? I've got to think of this x cubed minus 125. I've got to think of that as being something cubed minus something cubed. Right, I've got my 8 out front that we're done with. So the first one's going to be an x, isn't it? Right. So we're going to get x cubed is x cubed. Now what cubed is 125?
5.
5.
Said it first.
Okay. So for us then, instead of a's and b's, we have x's and 5s. We're just going to follow that pattern, right? So our answer then should equal 8 times what this pattern gives us for x and 5. Well, what's that tell us? A minus b, that's going to become x minus 5, right?
X squared
Times a squared is going to be x squared,
plus
plus ab is going to be
5x.
5x, and then b squared, 5 squared, is 25, right? Okay, and so then my final answer, I don't need those brackets in there, I've just got 3 factors being multiplied together. So my final answer just looks like my 8 that I have out front times this difference of cubes factored into x minus 5 times x squared plus 5x plus 25. That's it. You know, it's broken apart as far as we can break it apart.
Just fine.
Okay? Right?
What is this non-graph fraction?
This is non-graph, yeah. Okay, so now let's go down and let's look at another one of those. There's just gonna be some of these factoring ones. But the factoring ones, you know, once you've gone through a few of these, they're all the same. I mean, there's only 3 different strategies to use. Now, what about this one? How many terms? 4 terms. And so what's my strategy for 4 terms? Yeah, factor by grouping, right? Okay, can I pull anything out? Factor anything out of all those?
No.
No, I can't, so I'm just gonna group, right? 4 terms, I automatically know I'm just gonna break it into 2 groups of 2, right? First group gets the first 2 terms, 6x cubed minus 5x squared. Second group gets the negative 24x, don't forget the negative sign, right? Plus 20. And I know what this is, these kind always have the same kind of a pattern, right? I know that when I factor by grouping, from the first group, I'm gonna break out a greatest common factor, right? And I'm gonna have something left over. And then in the second group, I know I'm gonna have the same kind of pattern, right? And I know that whatever I get here, I have to get there, I don't even have a choice. If it's gonna work, those have to be the same. So what do I get from the first group when I can take out an x squared, right? Everybody agree?
Yes.
There's no number that goes into 6 and 5, but they both have x's, and I can take out an x squared. What's that leave me with?
6x.
Yeah, 6x minus 5, good. So I know this has to be 6x minus 5, and then the question is just, can I make that work? Yeah, if I take out a negative 4, that works, and I can check it. Negative 4 times 6x is negative 24x. Negative 4 times negative 5 is 20, right? And so now we can go down here, and so I've got the 6x minus 5s in each group that I can factor out. So I'll take each of these and pull those out front. And what am I left with? Well, if I take those away, I'm left with x squared minus 4, right?
That's it?
And so that's the factoring by grouping part. But we're supposed to factor completely, right? And so now we gotta ask ourselves, can I go any further? In the last example, we couldn't go any further, and we know we can't go any further because when we use the factoring patterns, we know that this quadratic factor that we get is never gonna get any smaller. It's just the way the pattern works. It's always gonna be done, right? But in this problem we're doing now, I've split it into a linear factor, which has to be done because it's linear, but then I've got this quadratic one. Can I do something with that one? Yeah, I can, that's a pattern, isn't it? That's a difference of squares pattern. X squared minus 2 squared. That 4 is really just a 2 squared, right? And so I can break that one down. I've got this other one that's already done. But this guy, I can split apart using the difference of squares pattern. And the difference of squares pattern, we know that one. A squared minus b squared factors how?
X plus 2x.
Well, okay, I mean, in general, a plus b, a minus b. So for us, instead of an a, we have an x. Instead of a b, we have a 2, right? X squared minus 2 squared. So I just get x plus 2x minus 2. Now I'm done. Got it broken all the way apart. Okay? Okay?
Okay.
Good. Okay, how about this guy then? Okay, now this one is, it's only got 2 terms, so it's gotta fit a pattern, if at all, right? Well, what's the pattern that fits? Difference of squares, good. So I gotta think of this, then I've gotta break this down into something squared minus something squared. What's the first something?
X.
Okay, x squared and 9 squared, okay. That's just that simple difference of squares pattern. So that one breaks up into x squared plus 9 times x squared minus 9, right? What we just did. Okay. Now we look at those, okay? Can we go any further? Does that one go any further?
No.
No, because there is no sum of squares pattern, right? Does that one go any further?
Yeah.
Yes, difference of squares. I can think of that one as being, instead of a 9, I could make that a 3 squared, and then I get x squared minus 3 squared, right?
Why couldn't you do that on the first one?
Because we only have 3 patterns. Remember that there is no sum of squares pattern. We have difference of cubes, sum of cubes, and difference of squares. And if you remember back, the sum of squares one always fails. It's never going to factor. Okay? So if you ever see one that would fit the sum of squares pattern, you can't do anything with it. It won't factor. Okay? And the reason it won't factor, I'll give you a quick way to remember that. What if I took x squared plus 9? What if I were solving an equation where I said x squared plus 9 equal to 0? I'd get x squared equals negative 9. So I'm going to get i's out of it, right? That's why it doesn't factor. Okay. Well, that helps you. It's consistent with that. Okay, so then the first one I'm stuck with. First one is done because it's a sum, right? So that's just going to stay x squared plus 9. What's the second one break down to?
X
There you go.
plus
X
3.
plus
Yeah,
x plus 3, x minus 3.
In Moodle, it doesn't matter which one you put first.
Makes no difference. Makes no difference. Okay. All right. Okay, find the greatest real solutions is all we care about, right? The greatest real solutions. We're not looking for imaginary ones. That's going to make this a little easier. So,
Wait, did you put that one in the quadratic formula?
we're going to. You're right. Okay, so this guy then. Now, first things first. Plus minus 3 is really just minus 3x, right? Okay, I could take out an x, right? I always want to see if there's something I can factor out. So the first thing I do is I can undistribute an x from this side, leaving me with 9x squared plus 5x minus 3. Agreed?
Yes.
Okay. Well, if I'm just trying to find the zeros, that's as far as I need to go, right? And once I get it broken down to linear or quadratic, I can set those factors equal to 0 and solve them, right? So this first one, if I set that equal to 0, I just get x equals 0. So that's one of my solutions. Now what about this one? If I set 9x squared plus 5x minus 3 equal to 0, well, that's chapter 5 stuff. How do I solve that?
Quadratic formula.
Yeah, quadratic formula,
Quadratic
right?
formula.
That's ax squared plus bx plus c equals 0, so I mean, we don't want to factor that. That'd be no fun. So we'll just use quadratic formula. So we get x equals,
Negative 8.
so negative 5 plus or minus square root 5 squared, right? Minus 4 times a times negative 3,
Divided by 8.
all divided by 2 times 9 by 18, right? Okay, and now this is one, and that's just a calculator issue, right? I know this is the non-graphing calculator test, but we would just put that into our calculator. We just want to figure out what is that going to be. I'm going to get negative 5 plus or minus. Now, what's that square root going to be? I'm going to get 5 squared, so that's going to be, if we just do that part, that's going to be 25. But now count the negatives. Minus, I got 2 negatives there, so it's going to be positive, isn't it?
Yeah.
Right? Plus 4 times 3 is 12, times 9 is 108. So inside there, I'm just going to get 133, right?
Yeah.
So I get plus the square root of 133 all over 18. So I'm just going to do that once for the plus sign, get a decimal answer, once for the minus sign, get the other decimal answer, and those are my answers, right?
Nice.
Okay? Make sense?
Yes.
Does anybody have a calculator? Here, let's just see what they are so we can, let's finish this one up so we can make sure we see how to input the answer.
I'll do it in my head real fast.
Okay, do that.
I don't know. Thought I had it. Oh, we got Asian in the back bag.
get for the plus sign, we get 0.3, I'll do it 3 places, 0.363.
Then it's like 9.2 cents.
The other one, if I take the minus sign, I get negative 0.918. Okay, and then the other one was 0, right?
Yep.
We had 3 of them. We had 0, we had that one, and we had that one. And what is the question asking us to do? They want to know the greatest real solution. Yeah, go ahead. So it's going to be 0, isn't it? Because those were old. Is that positive?
Yeah.
Yeah, so it'd be that one. Be that one, right? Because I had positive 0.363, negative 0.981, and 0. So that's going to be, whoops, that's going to be the greatest one. And I think they probably just wanted to 2 places. So 0.36. Okay, so let's put that in. 0.36. 2 decimal places. Okay. Okay, moving on. This guy. Okay, we can make this one. We can also do real easily.
4. Get rid of
It's a pretty strong word.
the
Yeah.
X squared. Minus 13x.
Okay, so what about this one now? How many terms? 3 terms. Can I factor anything out? No, I can't. Okay, but I've got 3 terms, so this is a quadratic one, right? This is a chapter 5 one. I've got 2 choices here. Can I find magic numbers that multiply to 16? I'm gonna show them both to you, because I want you to see this other one is really pretty easy. It's pretty quick. Can you find numbers that multiply to positive 16 and add to negative 17? Negative 16 and negative 1, that's right. Those are my magic numbers. So I could split this up, right, into my magic numbers are negative 16 and negative 1, and what goes there and there? X squared. Right? Because I have an x to the 4th and an x squared this time instead of x squared and x, like in chapter 5, right? And so now look, all I've got to do here, I've got this thing factored to where they're quadratic. I've got a product of factors equals 0, so just set the factors equal to 0 and solve. I'm either going to get x squared minus 16 equals 0, which if I solve for x, then I get x squared equals 16, so x equals, careful, plus or minus 4. Okay, and if I solve this one, x squared minus 1 equals 0 when x squared equals 1. So x equals plus or minus 1. So I get 4 answers. I get negative 4, positive 4, negative 1, and 1. They want the
Least and greatest.
They wanted the what? They wanted the least and greatest. So what would they be? Yeah, negative 4 is the least, right?
And 4.
Negative 4, positive 4. Okay, so that's gonna be right. Now, do I have to factor it? No, I don't have to. I can recognize that this is quadratic. So if I want to, A is 1, B is negative 17, C is 16, right? And I can just use the quadratic formula. Okay, but if I use the quadratic formula, here's the part I want you to be careful with. When I use the quadratic formula, I get negative B is positive 17 plus or minus square root 17 squared minus 4 times 1 times 16, right? All over 2. Okay, the main thing I want you to see is, what am I putting out front?
X squared.
X squared, right? Okay, and so if I did the quadratic formula, we already know what the answers are going to be, right? I know I'm going to get either x squared equals 16 or x squared equals 1. If I take the plus sign here, if I do all that math, it's going to give me 16, guaranteed, okay? and we won't take the time to do it, but if I were to simplify that, I would get, all that's gonna become, what's that gonna become? Shoot. It's gonna be, that's gonna, 225 is gonna be 15. So I'm gonna get x squared equals 17 plus or minus the square root of 225. That's what that's gonna be. So then, I mean, just that, we don't even have to, right? I just get 17 plus or minus 15 all over 2. And I'm gonna get those two answers. Everybody see that?
I see it, but
Okay. Either I'm gonna get x squared equals 16, which we already did, it's right there. Or if I take the minus sign, x squared 17 minus 15 is 2 over 2 equals 1, which we already did. Okay?
Oh, snap.
All right, so got it. Okay.
Boy, you're
So-
a genius.
You should become an engineer or something. Engineer something.
There's an electrical one, I don't know.
Okay, so what about this? Let's see. X equals 3 is 1 0 of this polynomial. Find, now you gotta read this carefully. It says find the least and the greatest of the remaining real zeros. So I'm gonna find the other zeros. What's the biggest and what's the smallest of those? Okay? So let's do this problem. Okay. No, I'm not gonna factor by grouping.
What is it? That's like grouping. What? So confused.
Okay, this is easier. We don't have to do any factoring here. They're giving us a 0, right? So what's our trick here?
But 3 input.
We're going to. We're gonna set this whole thing equal to 0. True. That's what we're trying to do. But if I'm doing that, if I'm setting this whole thing equal to 0, right? Now normally I'd have to factor that and set the factors equal to 0, but they're giving me one of the answers. One of the answers is 3, right? So so we can put that in for x and divide it through synthetically, right? And we can trim this down real easily. So then we're just going to do this. We're going to put this number 3, run that through, divide that factor out of 1x cubed minus 1x squared
Negative 30.
minus 30x plus 72. And we're already told that that is a 0 of the polynomial. So I know that's 0,
Drop
right?
one down.
So we drop the 1 down, times
3.
go ahead, Dally.
How you know it's 0?
Because it tells us that. It says x equals 3 is 1 0 of the polynomial. What's that mean? If it's a 0 of the polynomial, that means when I plug it in, I'm getting 0 for an answer.
And you plug 3 in?
Yep. So 3 is a solution to this thing when I set it equal to 0. So that means this has to be 0, right? So I bring the 1 down. 3 times 1 is 3 plus negative 1 is 2
Oh, 2.
times 3 is 6. Plus negative 30 is negative 24 times 3 is negative 72. So then what I'm left with is the quadratic factor, right? That's the constant, coefficient of x squared. So all I've got to do is set x squared plus 2x minus 24 equal to 0 to find the other zeros, right? And I could just plug those numbers into the quadratic formula. That'd be fine. That's a, b, and c, right? Or if it factors, that would be a little quicker. Are there magic numbers that multiply to negative 24 and add to positive 2? 6 and negative 4, right? So I could split this up into x plus 6, x minus 4. Now if I set those equal to 0 and solve, if I set x plus 6 equal to 0, I get x equals negative 6. If I set x minus 4 equal to 0 and solve, x equals 4. So of the remaining zeros, the remaining two zeros, those are the answers, negative 6 and 4. So the least would be negative 6. The greatest would be positive 4. We got it.
We're done for the day.
Getting there. Okay, well, we'll see what we can do. We are gonna probably not quite get through this thing, but that's all right. We'll get through as much as we can. What about, see if we can do one more? I tell you what, let's do, how about if we, this will be a quicker one. Let's do 15 and we'll do 14 tomorrow. Okay.
You just like did 15.
We pretty much did. Yeah, I agree. Pretty
So-
similar.
You know, it might be
Okay, so, okay, so that's what we want, isn't it? I guess we'll do that. And they want the value of k. Remember, they want the value of k, which is in there.
Can you just put that in your calculator as storing x at a certain number?
I mean, yeah, you could. No, but they tell you we're dividing this polynomial by x plus 2.
Oh, that's right.
So what's the number that goes out front?
2x minus 2
Negative 2,
equals 0.
right? We want the 0. So what we're doing is we're dividing this polynomial, 2x to the 4th minus 3x cubed minus x squared plus 0x minus 2, divided by x plus 2. That's the problem we're doing, right? So the 0 of the bottom is negative 2. The coefficients, putting in all, zeros 2, you're going to get 2. Because if I set the bottom equal to 0 and solve, right, that's the number that makes the denominator equal 0.
Yes, so negative
So
3.
2, negative 3, negative 1, and
Sierra
0.
Turkleson and Von
Negative
Herrera
two.
to the front office, please. Sierra Turkleson and Von Herrera to the front office.
And we're just trying to find k, which was that number in there. Right? So we bring the 2 down,
That's 4
times negative 2 is negative 4. I add those up,
negative 7
negative 7 times
Wait,
negative 2,
14
add
13.
Right.
Yeah.
56,
56.
plus negative 2,
54.
54. Buzzer beater.
We're electrical engineers, guys.